Please click on subscribe button and click on bell icon for more interesting updates on civil engineering concepts. Dear students, detailed civil engineering courses like manual building design, Stat Pro, ETAP, SAP, Revit, AutoCAD, Primavera, P6 are available at Civil Engineering Shravan online application app. So download the application from the Google Play Store now. Each course contains 50 plus high quality video contents and free PDFs and exercises, and online certification will be provided after completing the course. Course will be available at 67 to 70% discount now and valid up to 6 months. Download civil engineering application now from Google Play Store, or direct link is available at the description of this video. Try to utilize this offer. Hello everyone, welcome back to my YouTube channel Civil Engineering by Shravan. So in this video I will explain you complete introduction about the dampers and types of the dampers and applying of the friction dampers by using SAP2000 software. So dampers are very much important nowadays for reducing the seismic loading condition as per the IS 1893 code provision standard system. It is a part of earthquake resistant structural model. Okay, so if you consider any building which is presented in high seismic zone, let us consider zone 5 seismic condition. In order to decrease the seismic loading intensity, we need to proceed with the earthquake resistant building models. At that particular situation, we can use the bracing systems and shear wall systems or dampers, base isolations, etc. So but in this video I will cover you about the friction dampers and friction damper case which are presented by using SAP2000 software. So initially I will show you some introduction related to SAP2000 software dampers property. Then after that we will see about the properties and how to apply the dampers using SAP. So this is the PDF which is regarding the dampers introduction. So I will upload this PDF in Civil Engineering Shravan application free PDF section. You can collect the PDF and you can take the printout of the PDF for the reference purpose. So this is the properties of dampers and this is the basic introduction and types of the dampers. Basically it will be consisting of the dampers related to friction damper and again in the same process it will be consisting of friction damper, pall friction damper and metallic dampers. And it is having some other type is lead injection, lead damper. Okay, we can call it as lead damper also. So these are some advantages regarding the damper. But as per the list and types, we will consider only the friction damper as well as the viscous damper as per the accurate design results and as per the high ratio of the earthquake resistant structures. So that's why I will consider the friction damper as the example in this exercise. So just I'm selecting my SAP2000 software. Now we can see the software will be open here like this. Firstly go to file option, click on new model option. So here I am selecting initialization model as per kilonewton meter and default metric units will be in Indian. So just I am selecting 3D grid frame option. So number of stories as per my assumption, just I am taking 12 story building structural model and each story will be consisting of 3 meter. Number of base in horizontal I am taking 9, bay width will be of 3 meter and y direction will be of 9, each will be of 3 meter. And section properties we need to select, just I am selecting place mark, add a new property. Just I am selecting concrete which is of rectangle. So here I am selecting column which is having dimensions as 0.69. Again I am selecting 0.69 is the dimensions for the column. So here I am taking M30 grade concrete provision standard system for the particular column. So click on the reinforcement option here and we will select the HYSD. I will define one more HYSD which is related to Indian standard as per the concrete rebar provision of HYSD 500 grade. Click on OK option. So here I am selecting HYSD 500, again HYSD 500. So now I am selecting 20D longitudinal bars and confinemental bars. Just I am taking as 10D as per our assumption. So here I am taking 5 bars and this is the 5 bars. Just I will consider. So click on OK. Again we have to click on OK option. Now I will define the beam section. This time giving it as B, having the dimensions is 0.69 and width I am taking here as 0.3, or else you can consider it as 0.46. So click on reinforcement, select it as beam. So we will select here cover as 0.005, some 0.005. Click on OK. Again click on OK. Again we will select OK option. Instead of beam we will select it as beam. Click on OK option here. So that the complete model with the considerations of the beams as well as the columns will be open here like this. Now you can see this is the structure. This is the 3D view. We will make it as 2D view for this building. Again this is the 3D view. We will keep it as 3D view. So this is the ground level which is of z equals to 0. Now we will move to the first level which is z equals to 3 meter. These are the beams which are presented at this level. Now we will define the beams, slab thickness. For that go to define option, section properties, select the area section. Click on add a new section which is related to slab. Just I am taking the thickness of the slab is 0. Let us take 15 and this is also 0.15. M30 grade, click on OK, click on OK option. Now I will assign the slab section. Select this quick draw areas option. Just I am selecting slab section property. So just I am dragging here like this so that it will draw the slab section at this level. Again we will select this particular slab section. We will copy those slab section to the remaining model. But before that we will see this model in object field. So for that just I am selecting this right mark, general options, select here as fill objects, apply to all windows, click on apply, click on OK. Now we can see it was done with complete slab section. Now we have to copy these slab sections. Go to edit option for that, click on replicate option. So here we have to enter the number of replicates which is of 11 numbers and each replicate will be consisting of 3 meter. Click on apply option so that it will copy the slab sections to the remaining stories here like this. Click on OK. Now after this we have to define the load cases. Before defining the load cases, initially we need to apply the dampers for the building. So that is the important task. So before applying the dampers, we need to know the properties which are exist for that particular type of the damper. Okay, so for that just I am selecting here PDF. Now you can see this is the PDF which is related to the dampers introduction, and this is the reference PDF which is having properties of the dampers. Okay, so now we can see this is the mass of the particular damper which is related to viscous damper. Okay, viscous damper. So having the mass is 1700 kg, weight is 0.173 kilonewton, effective stiffness is 20,000, effective damping is 10,000. In the same process, viscoelastic property having 2000 kg is the mass, weight is 0.203, effective stiffness is 30,000, effective damping is 10,000. In the same process for the friction damper, we are having the mass is 2200, weight is 0.225, effective stiffness is 20,000, effective damping is 4,000. In the same process, tuned mass damper having 25,100 is the mass, weight is 0.25, effective stiffness is 5,000, again effective damping is 4,000. So now from this property I am taking link type property which is related to friction damper only in this example. So that's why we have to consider the data only related to this friction damper case. So for that go to define option here, select the section property. In the section property we will select a link support property option. Click on add option. So here I am writing as a friction damper. So just I am selecting the damper name is friction isolator. Property name is friction damper, friction. Okay. Now we will enter the mass which is approximately 2200. Again we will enter the weight which is approximately of 0.225. Again I am selecting the properties related to effective stiffness damping 20,000, 4,000. So select U1, click on modify. So here you can write it as 20,000 and this is 4,000. Now after defining 4,000 and click on OK option. So after this we have to click on OK. Now we have to click on OK option, friction damper here. So we have to apply the friction damper at this location, okay, which is approximately equal to 3 meter, 6 meter, this is 9 meter, this is 12 meter, 12 plus 1.5 meter, 13.5 meter from the center point of the building, this direction, okay. So this direction will be comes under X direction as well as the Z direction. So just I am selecting view option here, set 2D view, which is of this location. Just I am selecting this point location, click on apply option, so that it will open the particular location. So now we can see this is the top view which is having Z. So but here we have to select the XZ Z plane. So now we can see this is the center point, but here we have to select this point which is of minus 13.5. Click on apply, so that it will open the location here like this. Now we will draw the link support property. Now for drawing the friction damper, we will select this second option related to draw to link option here, and we will select the property name according to friction. So here I am selecting this first point, again I am selecting this second point, again in the same process I am coming to here. Now we can see it was drawn with the friction damper here like this. So here you can see this is the properties which is related to dampers, which is of damper exponential property. So we will define the damper, friction damper initially. For that go to define option. So we will select define option, section property. In this we will select the link support property. Just we will delete the property which is available here, and we will modify the add new property. Just I am selecting the property name is damper exponential. So here we have to select the type is damper exponential, and we will give the name as friction damper, FRI. Now we will enter the mass of the damper according to our assumption 2200, 0.225. So this is mass is 2200, 0.225. Again after this we have to enter the data related to effective stiffness as well as the damping here. So effective stiffness I am considering here, and damping as per the non-linear property type. Click on modify option. Effective stiffness I am taking here as 2200, and this is 4000. This is not 2200, this is 20,000. Effective stiffness is 20,000. So click on OK option. Click on OK. Now we will draw the dampers according to our assumption. For that we need to click on the view option here. Select the 2D view. So this direction will be of XZ plane. So now we can see the plane which is presented here is XZ plane. So we will select XZ plane, click on apply, so that it will open your view here like this in the front facing direction. So we will add the damper. So for that just I am selecting this second option related to quick draw joint links option. So we will select as friction damper. Just I am selecting this point, again I am selecting this point. Now you can see it was drawn here, damper here like this. Again if you want you can draw the dampers according to your consideration. So again I am selecting one more damper which is presented at this last corner location. Just I am drawing here. Again I am selecting here. Again in the same process I am selecting the first point. This is the again I am selecting this damper, selecting this point. Again I am selecting here. In the same process I am selecting dampers. Just I am selecting damper here. Select this point. Select this point. Select this damper type, select this point, select this point. Again I am selecting here, just I am selecting here, again I am selecting here. Okay, now we can see it was done with the complete assignment of the damper at this location. Okay, again in the same process we will apply damper in another side. Go to edit option, view, set default 2D view. Again we will select the point here at this corner. Click on apply, so that it will open the property here. So again I am selecting the damper property. Just I am selecting here point. So property will be a friction damper. Select here, again select here. In the same process we will draw the dampers at the right hand side corner also. So here I am selecting here. Again I'm selecting this property. Once again I will draw here. In the same process I will draw one more damper case. So this is the point. So this is the point I need to select here. Again I am drawing. Again I am drawing one more damper case. So I am selecting here this point, and this point. Now in the same process we will draw one more damper case. So I am selecting here a damper. This point, this point, this point. Okay, now you can see it was drawn here like this. In the same process we will draw the damper on the left hand side facing, right hand side facing also. Now we can see for all the sides I was drawn dampers here. So click on OK option. Go to select option. We will copy the dampers to the remaining stories here, which is of 11 numbers. So for that we have to select here dampers. Go to properties. Select the link property which is related to friction. So you can see here. Again we will go to edit option. Replicate which is related to Z, which is of 3 numbers. DZ having numbers is 11 numbers here. Click on apply, so that it will copy all the dampers which is presented for the building structural model here like this. Click on OK. So now after defining the dampers and applying the dampers, we need to apply the load cases according to our assumed data. So now here initially I am defining the load cases. Go to load patterns option. So here it was done with the complete date load. So here we have to select the live load condition system. Just I am selecting here as live. Add load pattern. Again in the same process we will add the earthquake load which is presented in X direction, which is of quake as per IS code provision standard system 1893 2016. Again I am selecting earthquake load which is of Y direction condition system. Click on add a new load pattern. Wind load which is of X direction. Just I am taking wind as per IS code provision standard system 1875 part of 2015 part 3, and wind load which is of Y direction condition system. Now we will modify the property which is presented inside this particular earthquake load X direction. Modify lateral load for that global X direction. So this is the type, soil type is 2, impedance factor just I am taking 1.5. Click on OK. Again I am selecting this, modify lateral load Y direction 1.5. Click on OK. Wind X, modify lateral load, just I am selecting basic wind speed is 44 with the terrain category. You can select the terrain category according to your assumption. Just I am taking terrain category of 4 with the mean importance factor as 1.31, and you can consider the wind direction angle is 0 and CP value is 0.86. I am taking 0.5. Click on OK. Again I am selecting wind Y, modify lateral load. This is 44, terrain category will be of 4. Again we will consider the wind direction angle is 90 here. Just I am taking, and this will be of value of 1.3. Click on OK. OK. Now we will apply the load cases. Firstly we will apply the self-weight by selecting all the building. Go to assign joint load forces. Select the global X direction as 1 1 1 1 1 1. Add to existing load. Click on apply option. So that it will apply the self-weight condition system. Click on OK. After this we will apply the wall loading condition system, which is the combination of external wall load, internal wall load as well as the parapet wall load. So external wall thickness which is of 0.23 multiplied by height of the wall multiplied by 20, so that it will make it as 13.8. In the same process internal wall 0.125 multiplied by 20, each will be consisting of 3 meters, so that it will make as 3. 7.5. 0.125 multiplied by 1.2 meter height is the height multiplied by 20, so that it will make it as 3. 3 plus 13.8 plus 7.5, so that it will make it as 24.3. This load will be applied for the beam sections. For that, go to select option, property, frame section, select the beam here, click on OK. Go to assign option, just I'm selecting frame line load, distribution condition, add to existing condition, which is of 24.3 kilonewton per meter intensity. We will select apply here, so that it will apply the load here. So click on OK option here. After this, we will add the slab load condition system. Go to select option for that, properties, area section, select slab, select close, assign. So select the area load, which is of uniform shell. Next I'm selecting dead load, which is a 1 kilonewton per meter square. Add to existing loading condition, click on apply. Again in the same process, we will apply the live load condition system. Just I'm selecting previous section, select as live load, having the intensity is 3 kilonewton per meter square. Add to existing, click on add. Again we will click on OK option here. Just I'm selecting OK option here. After this, we will apply the load combinations. For that, go to define load combinations option, default design combination according to concrete frame design. Click on OK, click on OK. Now we will apply the what we call support condition systems at the base. So for that, I am going to the base here. Just I am selecting all the node points at the base. Go to assign option, joint restraints, select as fixed support, click on apply, so that it will apply the fixed support conditions at the base for the building. Now we will do the analysis process for the building. Go to analyze option. So set load cases to run option here. Select the load cases if you want. So click on the run option, so that it will ask you to save the model. Just I am selecting here as dampers. So here I am selecting damper. Click on save option, so that it will do the analysis process for the building structural model with the considerations of the dampers. Now here you can see it was done with the complete analysis process. It is showing the deflection diagram for the building structural model. So this is the deflection. I will show you in 3D view. Click on 3D view option, so that it will show you the deflection diagram. In order to see the shear force diagram, bending moment diagram, click on display option, show forces stresses. So close it. Go to display, frame Spandrella force, cable option, select shear 22 option, click on apply, so that it will display the shear force diagram. And we will select the shear 33 option, click on apply, so that it will display the shear force diagram. Again click on the bending moment 33 option, click on apply, so that it will display the bending moment diagram. In the same process, you can see the other results also as per your convenient. Now after this, we have to design the building structural model. So for that, we have to go to design option on the top, select the concrete frame design, select view revised preferences, select code book as per IS code provision standard system, click on OK. So again go to design option, concrete frame design, start designing check option here, so that it will check the starting of the designing of the members as per your IS 456-2000 code provision standard system. Now here you can see it was done with complete designing of the members as per your considerations of the load cases and as per the definitions of the dampers case as per the friction consideration. So just I'm seeing the results part. So here I'm selecting this beam section which is presented here. Otherwise you can consider any one of the beam, right click on that particular beam section so that it will show you the complete summary which is presented on that particular beam section as per the IS 456-2000 code provision standard design. Okay, this is the beam section. In the same process you can consider the column section also. This is the column section, just I am taking here. So click on the summary option so that it will show you the complete summary results which is presented in this particular design as per IS 456-2000 code. So this is the complete process of designing of the building structural model and applying of the friction dampers to the building by using SAP 2000 software. If you have any questions regarding this particular building model and dampers, once text me in the below comment box so that I will give you the replies to that particular questions. Thank you for watching this video and see you in the next one.